This conference will now be recorded.
Hey, hi guys, welcome back. So we were talking about databases in Hive. So we're done with that. So we'll talk about tables in Hive. So a database is a combination of multiple tables put together. A table is a combination of multiple columns. So each column will have a respective data type, whether it is a numerical type or string type, etc. So that we have to define. So that's where we had to know a little bit about the data types in Hive. So these are the different types of data types in Hive. Let's try to understand about each of these. So the first one is nothing but integer type. So we will use the integer type especially to define the employee ID, student ID, product ID, customer ID, etc. And then Boolean type can have either true or false values, nothing else. Suppose if you wanted to understand whether a person is eligible for voting or not, whether a person is a senior citizen or not, either true or false values, nothing else. Coming to the next one, date type. Date could be for hiring date, date of birth, date of joining, etc. Coming to the next one, timestamp. So it will show the minutes, hours, and then seconds as well in your time. Suppose, let's say you wanted to find out the exact time at which the order has been placed in Amazon, right? So Amazon tracks their orders very closely. So maybe it must be using timestamp to define the date at which the order has been placed or the time at which the order has been placed. Moving on to the next one, string and varchar, they are almost same. They are generally used for the non-numerical fields such as customer name, student name, employee name, product name, etc. So we got some understanding about the different data types in Hive. We will try to understand the different types of tables in Hive. There are two types of tables in Hive, managed table or internal table. And the second type of table is nothing but the non-managed or external table. So let's get into the hands-on. Then I'll talk about some of the concepts. So I'll go to my Cloudera Quick Start VM. So this is my Cloudera Quick Start VM. So the first step I wanted to show you is how to get the data into the Cloudera Quick Start VM. So I'm going to show a file on my local machine for now. I'll go to my local machine. And I have this database, or I have the details about the retail domain. So there in retail domain, once you place an order, every order will have an order ID. So let me first show the data. I'm trying to open the file on my local machine in Notepad++. So this is the orders data. So the first column is nothing but the order ID. First column is nothing but the order ID. And second column is nothing but the order date, basically the date on which the order has been placed. And third column is nothing but the order customer ID. So generally speaking, the order customer ID should be either mobile number or email. But for simplicity, we have the order customer ID as a number, the third column. And the fourth column is nothing but the order status. Suppose you went for cash on delivery, right? Then the status could be pending payment. Let's say you have done the payment, then the order status could be processing. Suppose the order has been delivered to your place, then the order status could be either complete or closed, etc. So this is the data that we're going to use now to create a table in Hive. But this file is in my local machine. I somehow have to get this file into my Cloudera Quick Start VM. There are multiple ways, but the simplest way that we can use is I will share this file with you in Google Drive. You can download it into your downloads folder on your local machine and attach this file as an attachment in your Gmail and open the same mail on your Cloudera Quick Start VM. Let me show what I'm talking. On the Cloudera Quick Start VM, I'm going to launch the browser. So I'm going to launch the browser. So this is the browser symbol here. If you can click on it, you should be able to launch the browser. Click on it. So this is the browser, Mozilla Firefox. So try to type Gmail and click on the first link. And then try to click on sign in. Enter your email address. So basically, I'm trying to log into my Gmail account. So here, I'm going to search for orders. Yeah, so here is the file that I'm looking for. So this file, I have attached it 3 days ago. You can see that this is the file name. You can modify this file name, of course, but for now, this is the orders file that we're going to download. You can see scan and download option, click on it. And then click on save file. So the file has been downloaded. You can close this browser now. Just directly close it. Then open your terminal. Right click anywhere on the desktop. Say open in terminal. Maximize. Click on view and zoom in twice. So go to the downloads folder. Look at the complete path. Home Cloudera downloads. So this is the path. So here I can run lsfnlrt. This is the file. I want to rename this file by using mv command. Let's say the file name is orders.txt. I have this file now. Head space the file name. Now I can see the top 10 records. So this is how you can get the file from your local machine to the Cloudera Quick Start in simple way. Now you can go ahead and use this file. So now based on this data, I wanted to create a table in Hive. So let me first set the title, terminal, set title. Let's say I wanted to use this terminal for any HDFS or Linux commands. I want to open another terminal. How to open another terminal? Click on this icon. You should be able to open another terminal. So terminal, set title, give it as Hive. Click on OK. And then click on view and zoom in twice. Try to launch Hive here. Hive, hit enter. It will take 10 seconds to launch Hive. So the Hive shell has been launched. Again, as I told, ignore these 2 lines for now. We'll talk about these 2 lines later. For now, just focus on how to launch Hive. We have launched Hive. Then the next step is to see the list of all the databases. Show databases. I just have only default database. I am going to create a new database for today's session. Create database. If not exists, database name is, let's say, October 2022. You can give any name. For now, I'll go with this name. Again, in show databases, I have this database called as October 2022 created. I will switch to this database by saying use space October 2022. Show tables. I don't have any tables right now. So now I am going to go ahead and then try to create the tables within this database. I'll go to my desktop, right click anywhere, create document, empty file. Let's say I want to score tables. enter, open this file. So here I'm going to build my query. I'll take one sample record from the file, right click, copy it, go back and paste it here. So what's the first column here? This is order ID. This is order date. This is order customer ID. Then this is order status. So based on this data, I wanted to create a table in Hive. So create table, table name is orders. And here I have to define all the column names. First column is order ID, which is of integer type. Second column is order date, which is of timestamp type. Third column is order customer ID, which is of integer type. Fourth column is order status, which is of string type. Along with this, you also have to mention one line extra. Row format delimited fields terminated by comma. So what is the meaning of this line? If you can have a closer look at your data, every column or every field is actually separated by comma. Right? Have a look here. All these fields are separated by comma. Right? So that's where we have to mention that row format delimited fields terminated by comma. Let's copy this. Go to the Hive terminal, right click and paste it. Enter. So now you should have this table created. Show tables. I can see this table. But now the question is, we have seen that there are two types of tables in Hive. Whether is it a managed table or internal table or external table. So to figure out the table type, you have to say describe. Okay, let's do one thing. First, let's describe this table. So describe space orders. So this will give you just the column names on the respective data types. And by the way, you don't need to type describe fully. You can even give a shortcut. DESC also is fine. Both are same. But now to get more information, you can use describe, extended, and then the table name. So here I can, so this is a command that I have given, describe extended table name. I can see detailed table information, but unfortunately, this is not so great. I mean, it's not readable, right? Even though we have huge amount of information here, I can't read it clearly. So this is where I have to use something called as formatted. Describe formatted orders. Now this is better. I can see the column names and the respective data types. I can see the detailed table information. This table belongs to October 2022 database. It was created by the Cloudera user. You can see the time at which it has been created. And look at this. By default, whenever you create a table in Hive, it's a managed table or internal table. That is one of the interview question. And also you can see that the field delimiter is comma. But now, if I try to query this table, will I find something? Select star from orders. This is used to get the content from this table. There is nothing because we have just created the table, not yet loaded the data into that table yet. Right? So let's see how to load the data into this table. This is where I have to use load command. Load data local in path. Here you have to mention the location of your data. Where is your data? It's available under home Cloudera downloads folder. The file name is orders.txt. Home Cloudera, downloads. The file name is orders.txt. Into the table, what's the table name? Table name is orders. Right? Just copy this. Go to the Hive terminal, right click, paste it. Enter. Now have a look here. It's showing us loading data to the table October 2022.orders. So what is the meaning of this? We are trying to load the data into the table called as orders, and that table is part of October 2022 database. One more interesting thing that you should notice here is number of files is showing as 1. So what is the meaning of number of files as 1? So if I can scroll a little more up, you can see there is something called as location, right? Let's copy this entire path. Select that entire path, right click, copy it. Go to the HDFS tab, HDFS plus DFS-ls, right click and paste that path. Enter. You can see that we have a file here called as orders.txt. So, and by the way, one more important point that I want to make here is whenever you create a tables in Hive, by default it's a managed table or internal tables in Hive. That is clear. And whenever you create a table in Hive, it will create a corresponding directory in HDFS. So what is the meaning of this statement? So if we can go and check under this path, user Hive warehouse, in the last session we have learned that whenever you create a database in Hive, it will create a corresponding directory in HDFS under this path. So this we are clear. October 2022 that you are seeing right now is a directory for your database that you have created. And within that database, today we have created a table called as orders. If you go and query October 2022 DB, you should see a directory for your orders table. Have a look here. We have the directory for your orders table that you have created. Got it? Now, as we have loaded the data into this table, if you go further and check within this orders directory, you should see the file that we have just loaded. Have a look here. Now, if I query this table, I should be able to see the data. Let's go back here. Select star from orders. This will get me all the records from this table. But suppose total it contains 68,083 records. Suppose I just want to see top 10 records. Then I can say limit 10. I can see top 10 records. Right? So that's how we are able to load the data into this table and we are able to query it. But one more interesting thing that you should notice here is whenever you try to create a table, it will automatically create an entry in your Metastore DB as well, right? So now let's go ahead and try to connect to the Metastore DB, and then we'll try to basically see how that entry will look like. So I'm going to open another terminal. Terminal set title MySQL. What is this MySQL? Metastore DB, right? Click on view and zoom in twice. MySQL space hyphen u root hyphen p cloud. You guys, am I audible now? Can someone confirm?
Yes.
Yes. It
So
got
there was
stuck
a
for a while.
yes, there was a network issue. I'm back now. Yeah, sorry about the interruption. I'm back. Yeah, so we are able to connect to the Metastore DB by running this command, and I ran show databases to see the list of all the databases. And within this, you have to connect to this database called as Metastore. So I'm going to say use space Metastore, then say show tables. Again, there are plenty of tables, but we will focus on only one table for now, which is nothing but TBLS. Select star from TBLS. So to see this output clearly, I want to zoom out. So two things you should notice here is table type is showing as manage table and table name is showing as orders table. So this is the entry that gets created whenever you try to create a table in Hive. It creates this metadata entry in your Metastore DB. Now what will happen if we drop the manage table? Will it impact the actual data in HDFS and metadata in the Metastore DB? Let's find out that. So I'm going to drop this manage table now. Go to the Hive terminal. So before dropping the table, let's say show tables. Show tables. And then I'm going to drop this table. Drop space, table space, orders. So the table has been dropped, right? I don't see the table anymore. Now let's say select star from orders. So ideally speaking, this is the correct syntax, right? Select star from orders is the correct syntax, but I'm going to make an intentional typing mistake now. Instead of from, I'll give it as FRM. Hit enter. You can see it's showing us parse exception. So what have we learned in the first session of Hive? If there are any syntax errors such as this, then immediately the compiler will throw parse exception and the query will fail. Now, which component is throwing this parse exception? Compiler, because of the syntax issue. If I can go back to the architecture. So we are running our queries on Hive CLI. First, it's going to the driver. Driver is sending it to the compiler. So because there is a syntax issue, compiler is immediately failing with the parse exception. Now let's fix that syntax problem. Let me make it as FROM. Is this query correct syntactically now? Yes. Hit enter. Now this time you are seeing semantic exception. It's saying table not found orders. Now which component is throwing this semantic exception now? Again, let's go back to the architecture. So we are running the queries from Hive CLI. First point of contact is driver. Driver is sending it to the compiler. Is the given query correct syntactically? Yes, that is correct. Hence, it is passing it to the metastore DB. Now, metastore DB should check whether this table metadata entry is available or not. So that's where it will check the same in the metastore DB. So this is the entry before dropping the table. Now I have dropped the table. If I can go and query it again, I don't see that, because whenever you drop a managed table in Hive, it will drop the corresponding metadata entry as well. And because this metadata entry is not found by the metastore DB, it is immediately failing by throwing semantic exception. And it's saying that table is not found. And you can see that table entry is not there because we have dropped the managed table. Right? So, okay, we are good with respect to metadata. Whenever you drop your managed table, the metadata entry is gone. What about the actual data? So the actual data was available at this place, right? Will it still be there? Let's find out. It is not. So basically, whenever you drop your managed table, your metadata entry in the metastore DB is gone. Your actual data in the HDFS is also gone, because it will remove the entire table directory itself. See here, under October 2022.db, you don't have anything, which means because you have dropped orders table, the actual data is in HDFS, which is nothing but this orders directory, as well as the metadata and the entry in the metastore DB is gone. Remember that point. So this is very important. So whenever you drop a managed table in Hive, two things will happen. It will drop both the actual data in HDFS and then the metadata in the metastore DB. Now the question is, when should we go with the managed table? So you should go with managed table whenever you feel like the data that you are using is temporary. Also, when you want the complete control to be given to Hive, that is the entire management of the life cycle of the data and the table, that is right from the table creation, loading the data into the table, querying the table, as well as dropping the table, etc. If you want everything to be under the control of Hive, that's where we go with the managed table in Hive. Now let's talk about external table in Hive. How to create an external table in Hive? It's very simple. You just have to add a keyword called as external. That's it. That will create an external table for you. So let's do one thing. Let's try to create the external table for the same data. All I have to do is to just use external keyword. That's it. I'm going to use external keyword. Here the table name, I want to change it to ext. That is not mandatory. That is just for namesake. So basically, just to identify that this is an external table, I'm adding underscore ext at the end so that I can find it out easily. Now let's go ahead and create this external table. Copy this, go to the Hive terminal, right click and paste it, enter. Now we have this table created. You can just say show tables. I have this table created. So the first question is, how can I confirm that this is an external table? This is where you have to type describe formatted orders_ext. So this is the command that I've typed, and have a look here. Table type is showing as external table. Again, whenever you create a table in Hive, it will create a corresponding directory in HDFS, right? That's what we have learned. Now let's confirm the same. Here, there was nothing after dropping the orders table. Now I should see one more directory created for your external table, orders_ext. Have a look here, we can see orders_ext. We have just created the table. Do we have any data loaded? Not yet. To confirm, you can even check the contents under orders_ext. Do we have any contents here? Nothing. We have just created the table, not yet loaded the data into this table yet. Now, I'm going to go ahead and load the data into this table. Again, I can use same load command, no changes. Only thing which I have to change here is the table name, orders_ext. That's it. Everything else remains same. Copy this path, go to the Hive terminal, right click and paste it, enter. Observe the output carefully. Loading data to the table. What's the table name? Orders_ext. This is part of October 2022 database. Again, you should notice that number of files is showing as 1. What is the meaning of this number of files as 1? If you can go and query this location once again, you should see that file. Have a look here. We are seeing that file. And what about the metadata? There was nothing after dropping orders table, but as we have created external table, I should see an entry for the same. Have a look here. Table name is showing as orders_ext and table type is showing as external table. So we can create external tables in Hive just by using external keyword. Again, whenever you try to create an external table in Hive, it creates a corresponding directory in HDFS as well as an entry is created in the metastore DB as well. That's what we have seen, right? Now let's query the table. Let's query the table. I'll go to the Hive terminal. Select star from. What's the table name? Table name is orders_ext. We want to see only top 10 records, then try limit 10. I can see top 10 records. So there is one question which I got in the chat box to me. Can we view the data in HDFS here? Okay, so I think maybe to answer this question, I think copy this full path, copy this HDFS space DFS hyphen tail, give that path. Is this what you are looking for, Priya? Does that answer your question? Okay, cool. I think we're good. So we have seen that whenever you create an external table in Hive, it will create the corresponding directory in HDFS, which is nothing but your actual data, and the metadata is created in the metastore DB. Now comes the question, what will happen when you drop an external table? Let's do that. So I'll go to Hive terminal, show tables. So I have only one table now. I'm going to drop this. Drop table. Table name is orders underscore ext. So the table has been dropped. Show tables. I don't have any tables. Let's just select star from orders underscore ext. Again, this time, so I'll miss E from select, right? Is this query correct syntactically? It is not. You should see parse exception again. Again, which component is throwing this parse exception? Which component is throwing this parse exception? Again, the parse exception is actually coming from your compiler. So the first point of contact when you run your Hive queries is driver. Driver will send it to the compiler. If there are any syntax problems, immediately compiler will throw parse exception and the query will fail. And that's what is happening now. So the query is not correct syntactically, it is failing. Let's fix that syntax problem. Let me put it back to select. Select star from orders underscore ext, which is correct as per the syntax. This time I'm seeing semantic exception, table not found, orders underscore ext. So what's going on in MetaStoreDB? This is before dropping the external table. I have dropped the external table and the metadata entry is gone. So basically here this query is correct as per the syntax. So basically it's passing the compilation check. So we are running the queries from Hive CLI. It's going to the driver. Compiler is saying, okay, the query is correct as per the syntax. Then it's passing it on to the MetaStoreDB. Now MetaStoreDB is saying that, okay, I don't see that entry anymore. Hence it is failing with semantic exception, saying table not found. Right? Okay, so what about actual data then? Actual data should be there in HDFS. Right? Let's go and check that. So it was supposed to be here under orders underscore ext directory. Do we still have it? Yes, we do have it. So the main important point which I would like to convey here is whenever we drop an external table in Hive, it will drop only the metadata and the MetaStoreDB. The actual data in HDFS still remains untouched. No changes to your actual data. So this is one of the very important interview question. What is the difference between managed table and external table? Of course, there are a lot of other differences, but I would highly encourage you to talk with respect to dropping of the table. That is, whenever you drop a managed table in Hive, it will drop both the actual data in HDFS and the metadata in the MetaStoreDB. But when you drop an external table, it will drop only the metadata entry, but your actual data still remains untouched in HDFS. Now the question is, when should we use external table? So most of the times in the projects we'll be using external tables only. So you will use external table whenever you feel like the data that we are going to use is permanent, and also when the data is used outside of Hive. For example, the data files are read and processed by an existing program. So we haven't spoken about Spark yet, but we will see how to integrate Spark with Hive. That's where if you're trying to create something called as data frames in Spark, and if it is using the data from Hive, then if you go with managed table, if you drop your managed table, that will have an impact on Spark. To avoid all such impacts, it is highly suggested to use external table so that even if you drop your table, the other programs or other applications, whichever are using that data, won't be impacted. Okay, I think that's what I wanted to convey. Now, we are using a separate terminal to run the Hadoop commands. So is it, okay, let me go back to the second point. Okay. So, okay, let's talk a little bit more about second point once again. So we will use external table in Hive, especially whenever you feel that the data that you're going to use is permanent. That is, right now we are just using Hive, but going forward we'll further integrate or further see how to use Hive with other components as well in big data world. That's where if the other applications or other components in big data are using Hive, then if you go with managed table, what will happen if you drop the managed table? It will drop your actual data also. The other applications such as Spark, if it is using that, it will have an impact. To avoid all that impacts, we can use external table so that the data that we're going to use is permanent. Even if you drop the table, your data will still be accessible by Spark. Does that answer your question? Okay, so coming back to the point, so we were running Hadoop commands in separate terminal, right? Now the question is, can I run Hadoop commands in Hive terminal? Can I run Hadoop commands in Hive terminal? The answer is yes. So what you should be doing is just take this command as it is, right click copy, go to the Hive terminal, right click and paste it. And you should end with semicolon, hit enter. It will fail because you have to remove HDFS from the first. It should work. You should get the same output. So you don't need to run Hadoop commands on a separate terminal. You can run your Hadoop commands on the same terminal. Okay, pretty much this is what I want to cover, guys. So there's more hands-on to do. I think we are good to take a break for now today. We'll meet tomorrow again. Okay, see you tomorrow. We'll do more hands-on. Bye for today. Bye-bye.